Hi everyone, this is Saad Aslam and welcome back to this exciting series on competitive programming. So till now we have discussed a couple of problems on different data structures. I will add the link of the playlist in the description below, so you can check the playlist after this video. So today we are going to discuss a very important topic and a question, that is binary search. So if you have any technical interview scheduled or upcoming, or you are preparing for that, then there are many chances of getting a question from binary search. So before moving on, make sure to subscribe the channel and all of the YouTube stuff. So first discuss the problem statement. So given an array of integer nums and which is sorted in ascending order. So the main part is it is sorted in ascending order. Okay, so you have to return an integer target. So write a function to search target in the nums array. If target exists, then we have to return the index of the of it. Otherwise, we have to return -1. So that's a basic problem statement. And here in the example one, you can see there are elements like -1, 0, 3, 5, 9, and 12, and you have to find the target, that is 9. So the output is 4, like, because as 9 exists at the index 4, 1, 2, 3, 0, 1, 2, 3, 4. So it is exists at the index 4. Similarly, in example 2, the elements are -1, 0, 3, 5, 9, 12, but the target is 2, and the output is -1 because the 2 doesn't exist in the array. Okay, so there's the problem statement. Let's discuss the approach of it in our whiteboard section. So let's move on to our whiteboard section. So let me just erase. Okay, so here you can see in the whiteboard section we have an array of numbers and the target is 9. So the approach is like we are going to use 3 pointers like start, mid, and end. And start will be like as the starting of the array, and will be the length of the array. And we have to that these 3 pointers will act as the indexes. Okay, so we have to check 3 conditions, like if the element at mid is equals to target, then we simply have to return the mid, like mid will be the index. Okay, otherwise if the element at mid is greater than the target. Okay, so like element at mid is greater than the target, it means like target exists in the first type, like before mid. Okay, so we have to decrement the end pointer to mid -1. And the third condition is like if the element at mid is less than the target. Okay, so element at mid is less than target, then it means the target exists in the second half, so we have to increment start pointer to mid +1, and we are going to check these conditions until we find the target. Okay, so let's run this in our whiteboard. So as start will be 0, end will be the length -1, it will be 0, 1, 2, 3, 4, 5, 6. And mid will be the start plus end plus divided by 2, it will be 3. Okay, so the element at index 3 is 0, 1, 2, 3, it is 5. Okay, so we have to check that element at index mid is equals to target or not. So if 5 doesn't as 5 not equals to target, so we have to check the other 2 conditions, like the element at mid is less than the target, so it means that the target exists in the second half. Okay, so what we will do is like we will increment the start pointer to mid +1. So as mid is 3, so as mid is 3, let's first remove it, and start will be mid +1, it will be 4. Okay, so 4, and new mid will be 6, 4 plus 10, 10 divided by 2, 5. Okay, 5. So let's now erase this. Okay, and our new mid is at 5. Okay, 0, 1, 2, 3, 4, 5, it is at 12. Okay, So if 12 is equals to 9, no. So as mid is greater than the target, so it means that target exists in the like we have to decrement what we have to decrement the end pointer, like it exists before the mid. So at mid minus 1 will be 4. Okay, so mid minus 1. Okay, so mid is 4, and mid will be what will be like start plus and 8 divided by 2, 4. Okay, and what element is that index for? It is 0 1 2 3 4. Okay, so as 9 is equals to 9, we have to simply return the index. So what the index will be, we have to return the mid. So mid is 4, so we will return 4. So that's the approach of it. So I hope you understand the approach. Now let's try to implement this in our coding part. So let's move on to our coding part. Okay, so here you can see we have given a function search, and there are two parameters. One is the array and the other is the target we have to find. So like first we will check if the length of the array is less than 0, then we simply have to return -1, that nums dot length is less than 0. We simply have to return -1. Okay, now let's make 3 pointers. Okay, so it will be start, as start will be equals to 0 for the initial, and int end, it will be the length -1. Okay, and mid we will make this in after. Okay, so let's make a loop while like start is less than or equals to length. Start is less than or equals to end. Okay, so let's make our mid will be start plus, it will be end minus start divided by 2. So here we can find the mid of the middle element, mid index. So if the first condition, like if the element at mid is equals to what, target, then we simply have to return the mid. Okay, so that's the first condition. Else if nums at mid is greater than the target, so it's like nums at mid is greater than the target, then it means the target is less than the mid. So we have to decrement the end pointer. So end is equals to mid -1, and the third will be else. For the we are going to increment mid will be mid +1, and after the loop ends, we are simply, if none of, like if the element doesn't exist in the whole loop, we are simply going to return -1. Okay, so let's just check for any typos. If nums is less than this, while start is less than this, if n -1, if nums at mid is greater than. Okay, so let's run this code. Okay, we cannot find, oh sorry, it is nums dot length -1. Okay, Okay, so here you can see the solution is accepted. Now let's submit this code. So here you can see it has been submitted successfully. So I hope you have understand the problem and the approach of it. So make sure to subscribe the channel and hit the bell icon too. And till then, see you in the next video, and bye bye.